Okay, as I mentioned, looks like we have a variety of answers for each one, and some people are pretty honest, and that's totally fine. Okay, so um, let's go through this. So the first one is we have AB plus C over D. Okay, and um, if I don't remember something, I go back to the basics, right? What do I know about regular fractions? So for example, right, if I have um, 1 over 2 plus, say, 3 over 5, right? How am I going to add those fractions? What do we need in order to add the fractions?
A common denominator.
Exactly, a common denominator, right? In this case, the least common denominator, correct? So the least common denominator, all right, is going to be what in this case? 10. Very good,
10.
right? 10. Perfect, right? 10 is the least common denominator. So that means then, in order for me to add these two fractions, I would multiply this by what? 5 over 5 on this side. And on this side, I would need 2 over 2, okay? So now I would have what? 5 times 1. When you multiply fractions, you multiply across. So 5 times 1, we get 5. And then 5 times 2, we get 10, okay? And this one here, we get 3 times 2, which is 6, and then 5 times 2, which is equal to 10. So now we have the same common denominator. Now we can add these fractions. So the denominator here stays the same for 10. Then we do 5 plus 6 on the top, which gives us 11 over 10. Okay? All right? So that's what I do. If I look at something, it's all variables. How do I do that if I have, real practical numbers to put in? Okay. That's what I always think about. How do I go back to the basics? How do I use the basics to apply what I know about adding fractions? All right. So then in this case, I'm going to do exactly the same thing. Okay. All right. So in this case, what's going to be our LCD? What's our LCD here? Our least common denominator? BD. Thank you, Melanie. Right? So BD, right? BD would be our least common denominator. So that means then I would need to multiply this, right? Because I only have a B. I need to multiply this by D over D. And then this one I need to multiply by B over B. Does that make sense? All right. Now, multiplying is commutative. So 2 times 3 is the same thing as saying 3 times 2, right? It's 6. It doesn't matter which order you do it, you get the same answer. So same thing here. I can write this as DB or I can write it as BD. Okay? Right, they're the exact same thing. But I like to put them in order, in alphabetical order. So I'm going to write this as AD for the first part, and then BD on the bottom here, right? So for my first term, and this one would be BC over BD, okay? So just to have some order, I like to put them in alphabetical order, right? So again, the denominator is still going to be BD. We don't add them, we keep them as, you know, as the common denominator, and then we add the numerator. So we would get AB plus BC. Then that will be our answer there. Okay, which a lot of you got. Okay, which is wonderful. Okay, all right. Any questions on this part? Okay, now the second part here, okay, we're going to do exactly the same thing. What's the only difference? We have a subtraction, right? So everything is the same. All right, everything is the same except that now we have a subtraction. So again, our least common denominator is still going to be BD. So that means I'm going to multiply this by D over D, and this one I'm going to multiply by B over B. So that gives me AD over BD minus BC over BD, which gives me AD minus BC over BD. Okay, all right. Now, if you are falling behind on the notes, again, I can slow down, but you can also take a snapshot with your phone. if you are a little bit behind. So FYI. Okay. Okay. Any questions on number 1 or number 2 here? Okay, cool. Okay, what about this one here, number 3? Number 3. What do we do first? Anybody remember? So again, let's go back to
Do you do keep it,
basics.
change it, flip it? Would you keep the
Exact
first part of it and then
exactly.
multiply and then flip it upside down so the D would become
Yes.
up top and then the C would go
Very
on the
good.
bottom?
Excellent. Very good. Right. So that's exactly what you do. So let's go back to the basics. Right. So let's go back to our problem here, our example. 1 over 2 divided by 3 over 5. Okay. So again, we're going to keep 1 over 2. All right. We're going to change the division to a multiplication. And then we're going to what? Flip this. 3/5 now becomes 5 over 3. Okay. And then you just multiply across. So that's going to give us 5. 1 times 5 is 5. And then 2 times 3 is 6. So we get 5 over 6 there. Okay. One thing I forgot to mention, make sure you always circle your answers. Okay. Yeah, and if I do make a mistake, I mean, I am human because I'm talking and trying to write at the same time. Let me know. So one person's already pointed that out, which I appreciate. Okay, so yeah, so I had AD plus BC, but I wrote AB. Okay, so please change that. So I'll get going, and sometimes what I write down is not what I said. So AD, okay, make sure you change that to AD plus BC over BD. Thank you. Appreciate that. Okay. All right. Again, if I make a mistake, let me know because I'm talking and writing at the same time. Okay. All right. So again, for this one, we're going to do exactly the same thing. Okay. Exactly the same thing. So I'm going to keep AB. Okay. And then the division will become multiplication, and then I'm going to flip the CD, and that becomes D over C. Okay. Then we just multiply across. So A times D is AD, and then B times C is BC. And then there's our answer there. Okay. All right. And then the last one is simple, right? Same thing. We don't have to do anything special. We just multiply directly across. So we have AC, BD. Okay. Any questions on these 4? Okay. Okay, so let's focus on the quadrants first. Okay. So are the quadrants properly labeled? Yes or no? No. All right. So a lot of people are saying no. That is correct, right? All right. None of the quadrants are properly labeled. So you would circle every single one of these, right? All of these are labeled wrong. Okay. So let's look at quadrant number 1. Okay. Quadrant number 1. Where does quadrant number 1 go? The top right, top left, bottom right. Where does quadrant 1 go? Top right. Very good, right? So quadrant 1 is going to go to top right, right? This is really important, especially if you go into trig. All right. So quadrant 1 is top right. Then where's quadrant 2? Top left, bottom right. Top left. Perfect. Okay. So quadrant 1 is here. Quadrant 2 is here. How about quadrant 3? Bottom left, bottom right. Perfect, right? So bottom left. 2, 3. Okay, so it goes counterclockwise. Okay, and that's important. Again, if you get into trig, it talks about the unit circle, and 0 starts on the x-axis, and the positive degrees go counterclockwise. Anyway, that's one of the reasons why it's labeled this way. Quadrant 1 is top right, quadrant 2 is top left, quadrant 3 is top bottom left, and quadrant 4 is bottom right. Okay, what do we know about the numbers on quadrant 1? Are they positive, negative? What are they? What do we know about positive? Good, right? So these are positive, right? So you have x and y coordinates, and both are going to be positive, correct? What about quadrant 2? What do we know about that? Quadrant 2, what do we know about that one? Good, negative, positive, excellent, right? So negative, positive. How about quadrant 3? Negative, negative, excellent. Okay, and then how about quadrant 4? Positive, negative, perfect. Okay. Wonderful. Okay, so again, that's really important to know those. Okay, so now let's label the axes. Are they labeled correctly? I mean, correctly. Is this where the x-axis is? No, right? The y-axis is not there. This is not where the origin is. So again, you should have also list that down or circled that the axes are not labeled correctly. So the x-axis is here, the y-axis is here, and then the origin, I'll just put that O for the origin. Okay? How about 4, 3? Is that labeled correctly? No, right? This one's not labeled correctly, so you should have circled that, and then here you would write it down or plot it correctly. So 1, 2, 3, 4, 1, 2, 3. Okay, so that's 4, 3. This is 4, 3. Okay, 6, 5, is that one correct? No, right? So again, I would go here and properly label it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So here's 6, 5. Okay. Negative 4, 6. No, that's not correct either. So I'll go here and properly label where negative 4, 6 is. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so here's negative 4, 6. All right, negative 4, negative 3. Again, that's not correct either. So 1, 2, 3, 4. 1, 2, 3. Okay, so that's negative 4 and negative 3. And then 0, negative 4. Where's 0, negative 4 going to be at? 0, negative 4. Where would that be at? Y-axis. Perfect. Yep, on the y-axis. Excellent, right? 0, negative 4. Again, this is not where it is. 0 means we start the origin, and negative 4 we go down. So 1, 2, 3, 4. Okay, so there's 0, negative 4. Okay. All right, just curious. Give me a thumbs up if you got them all correct. Okay, perfect. Only one person got them all correct? Okay, good. All right, thank you. Okay. All right. Any questions on here? Okay. All right, let's go to the next part. So again, I'm just doing a little bit of review here to help with the first section. Okay, let's talk a little bit about radicals. Okay, radicals. Okay, so radicals. So we want to break this down in radical format. So simplify this. Okay, we want to simplify the radical. Okay, so let's say we have, but before we do that, let's talk about perfect squares. Okay, can you give me an example of a perfect square? What's an example of a perfect square? 16, good. Okay. All right, what's another example? 9, good. What's another example? 64, good. So somewhere down here. 100, good. All right. Perfect. 81, right? So how are we getting these numbers? What are we doing? What are we doing? How are we getting these? A multiplied number by itself. Perfect, right? So 1 times 1 will give us 1, right? 2 times 2 will give us 4. 3 times 3, right? Will give us 9. 4 times 4 will give us 16. Okay, then we have 25, uh, 36, right? 5 times 5, so on and so forth. So literally, if you think about it, if you were to draw this, this is a 1 by 1. Okay, this is going to be a 2 by 2. This is going to be a 3 by 3. Okay, so um, so geometrically, that's what it would look like, right? Algebraically, it would look like this in the middle, right? You're just multiplying a number by to itself. All right, so when we deal with radicals, we need to think about the perfect squares. Okay, so as we know, right, the square root of 1 is 1, right? The square root of 4 is 2. The square root of 9 is 3, right? So on and so forth. Okay, so again, when we simplify this, we want to find out when we break them down perfect squares because we know that those can be simplified easily. Okay, but if we have like a square root of 5, we don't know, right? It's going to be some decimal answer, right? It's going to be like 2 point something. Okay, so but again, it wants us to simplify in radical form, so we need to leave it in radical form in the end. Okay, so let's say we have radical 12. All right, we need to simplify radical 12. Well, let's go ahead and list down the factors of 12. So what are the factors of 12? What are the factors of 12? Okay. What are they? What's two numbered when you multiply gives you 12? 3 and 4. Good. Okay. What else?
2 and 6.
2 and 6. Okay. And then 1 and 12, right? Those are the factors of 12. Correct? All right. So when you do this, you want to pick the number. Well, first of all, 1 is a perfect square and 4 is a perfect square, right? But you want to pick the highest perfect square of the pair. Okay. So you will want to pick these two right here because it has 4 as a perfect square, which is the highest perfect square of all of the lists. Okay, so when I break this down, all right, I'm going to have radical 3, then inside he'll be radical 4, 4. So inside the radical will be 3 times 4, and then I break that down to radical 3 times radical 4. Okay, and then this is what? Radical 3 times 2, which I can write as 2 radical 3. All right, so will be the simplified form of this. Okay. Okay, so let's try another one. So let's say we have radical 32. Okay. So what are the factors of radical 32?
4 and 8.
Okay, 4 and 8. Okay, what else? So we have 32 here. We have 4 and 8. What else?
2 and
1
16.
and 32. Okay, 1 and 32. Say it again. I'm sorry.
2 and 16.
2 and 16. Good. Okay, anything else? I think that's it, right? Okay, so again, we got a couple of perfect squares, right? We got 4 here, we got 1 here, we got 16 here. So which pair will we pick? Which pair will we pick? 2 and 16. Why? Because it has the highest perfect square. I want to pick these two right here. Okay, so in this case, this is going to be broken down to 2 and 16. Okay, and so this would be radical 2 times radical 16. Well, we know that radical 16 is 4. So then this becomes 4 radical 2. Okay. All right. So why don't you guys try one? All right. So let's say we have 3 times radical 162. Okay. 3 times radical 162. Okay, so I'm going to have 162. Oops. Okay. And so I need to find factors of 162. So we have, of course, 1 and 162. Okay. And then I have here 2 and 81. We have 3 and 54. We have 6 and 27. We have 9 and 18. Okay. And then I think that's all. All right. So again, they just start doing division. 162 divided by 2, 162 divided by 3, 162 divided by 4, so on and so forth. And you start to see what your factors are. Okay. And you want integers, you don't want any decimal answers. Okay. So in this case, which is our highest perfect square? What's the highest perfect square here?
81.
81, right? 81 is the highest perfect square. So that means this is the pair that I want, correct? All right, so I'm going to have, again, 3 times the square root of 2 times 81. Then I'm going to break this down to radical 2 times radical 81. Okay? All right, so that'll be 3 times radical 2, and then radical 81, well, that's just going to be 9, right? Then I'm going to put the 3 and the 9s together. So that'd be 3 times 9 times radical 2. So 3 times 9 is 27. And then we have radical 2. Okay, and then there's our answer. All right. So if we have this triangle here, if we count, right? So this is 1, 2, 3. So there will be, the height will be 3. Okay, what about the bottom of this triangle? What's the the base, the length of that? 4. Good, right? Count. 1, 2, 3, 4. So there's a width of 4. Okay, so this would be 4 here. Okay, so if we have the height is 3, the base is 4, how do we find this slanted part? What's that called? Anybody remember? Anybody remember what that is? It's a slope, yes. But in triangle, anybody remember what that thing is? Yes, very good. Hypotenuse, right? So this is the hypotenuse. All right. That's the hypotenuse, which is the longest side of the triangle. Okay. And directly across the hypotenuse, you have this little box. Okay. So this little box here. What does little box indicate? What does that little box indicate? A right angle, right? So this little box here represent a right angle. Okay. Which is what? 90 degrees, correct? All right, so a little box. So again, always directly from the hypotenuse is the right angle and vice versa. Across from the right angle is the hypotenuse. So does anybody remember, how do we calculate the hypotenuse? How do we calculate this side? Pythagorean theorem, perfect. All right, the Pythagorean theorem. Okay. All right, which is a squared plus b squared equals c squared. Okay, so if I had in this form here, okay, here's my right angle. This will be my a, that's my b, and then that will be my c. Okay, so in this case, then my a, if I were to match it with this this triangle that I just drew, my A will be 4, right? 4 square. B will be what? 3 square. And C is I don't know, right? This is my C. I don't know what that is, so I'm going to leave that as C. Then I just solve for C. So 4 square is going to be 4 times 4 is 16. 3 square is 3 times 3, which is 9. And then C square is just C square. And then 16 plus 9 is going to give us 25. All right, and then how do we get rid of the square here? Take the square root. Excellent, right? So we take the square root. So the square and the radical go away, and we get 5 as our answer. Okay? Okay. So any questions on that? Okay. Let me pause this for a second. All right, so in this section, this is 2.1 distance formula, all right? And the distance formula says you can take, so first of all, why would we need a distance formula? So if we have the Pythagorean theorem, right? The Pythagorean theorem, you can use a squared plus b squared equals c squared. But not everything is all right angles, right? Not everything is a right triangle. So what if you have like two random points in some coordinate plane? How would you find the distance between those 2 points? Okay, so it's always not so easy drawing it or trying to make a right triangle if that's possible. So one thing we can do is we can use the distance formula. So you give me any 2 points on the coordinate plane, and I can tell you exactly the length of those, the distance or the length of those 2 points. All right, so basically the distance formula says you take the square root of x2 minus x1 squared plus y2 minus y1 squared. So remember the difference between when you have x2 on the top and x2 on the bottom. The 2 on the top, that is an exponent or a power. So it's like saying 3 squared, which is 3 times 3, which is 9. The x2 on the bottom is called a subscript. So it's talking about the second x. So you can have multiple x's, x1, x2, x3, so on and so forth, but it's just talking or referring to the second x. Okay, so that's the difference between what those two numbers or two notation means. So here what we want to do is we want to plot the points and find the distance. So let's plot that real quick. Okay, so I have negative 1, 1. So negative 1, 1. All right, so there's my P1. And then I have 2, 2. So 1, 2, and up here. All right, so here's P2. So what they want us to do is find the length, the distance between those 2 points. All right, so there's P1, there's P2. Okay, so how do we do that? Well, we're going to use the distance formula. It's plug and chug. Okay, so, but it can get tricky, especially when we start simplifying the radical. So in this case, I'm going to, pick which is going to be my x1, y1, x2, y2. It doesn't matter. All right. In the end, you get the same answer. But just for, in this case, I'm just going to label this one, my P1 as my x1, y1, and my P2 as my x2, y2. Okay. So in this case, I'm going to have x2, which is 2, minus x1, which is negative 1. All right. There's always a minus there in the middle, and that's going to be squared. Okay. Plus y2, which is 2, minus y1, which is 1, and that's squared, okay? So again, this is all under the radical, so remember that. All right, so two negatives is going to give us a positive, so we're going to have 2 plus 1, okay? And that's going to be squared. And then we got 2 minus 1, which is 1 squared, okay? So again, still under the radical, okay? And then 2 plus 1 is 3, so that'd be 3 squared plus 1 squared. All right, so that's going to give us 3 squared, which is 9, plus 1 squared is 1. So our answer will be radical 10. Okay. Okay, any questions on that one?